Greetings, everyone. I'm re-recording the solutions for the second practice test. I did this once and the audio got messed up. I'm going to use the same exact writing that I did. I'm not going to rewrite it. So I'm going to try to get through this very quickly because there are lots of things to do. If you have further questions, please reach out to me so I can be of help. So for question number two, what did they tell us? The functions f, g, and h are twice differentiable. G of 2 equals h of 2 equals 4. And then this line y equals 4 plus 2/3 times quantity x minus 2 is tangent to both a graph of g and g at x equals 2 and the graph of h at x equals 2. The first thing they wanted us to find was h prime of 2. A lot of you made a mistake and told me 4 for whatever reason. H of 2 is 4, as they told us, but not h prime of 2. H prime of 2 is the slope of the tangent line to the graph of h at 2. Then they gave us the tangent line right here. What's the slope? It's the 2/3 right there. So h prime of 2 should be 2/3, and that's it for part A. It should be an easy question, but a lot of you missed it for some strange reason. Now for part B, let A be the function given by a of x, which is 3x cubed times h of x. We want to write an expression for a prime of x and then find a prime of 2. And so this is a product rule problem. So you're going to just apply the product rule. Some of you didn't do that for some strange reason, and it should be pretty straightforward that it's a product rule problem. So we had 9x squared times h plus h prime times 3x cubed. And then we just plug in 2, and we got to do some arithmetic. Now we found uh, h prime of 2 from the previous problem, so that's where the 2/3 came from here. H of 2 was given to us as 4, so 2 squared is 4 times 9 is 36, times h of 2, so times 4, and then the rest is just arithmetic. Now for part C, they tell us that the function h satisfies this relationship right here, x squared minus 4 divided by the quantity 1 minus f of x cubed. I think that says, yeah. For x not equal to 2, it is also known that the limit of h of x as x approaches 2 can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2, and then show some work. Some of you said h prime, you found h prime. No, you didn't find h prime. Some of you wrote h prime equals, and then you applied L'Hopital's rule. Don't do that, okay? When you take the derivative of the numerator and then take the derivative of the denominator, that's not h prime, okay? H prime would require the quotient rule. I don't want you to do that, but don't mislabel L'Hopital's rule either. They'll penalize you for that. So we're taking the limit as x approaches 2 of this function, and they're saying that L'Hopital's rule can be used to evaluate it. Notice the numerator becomes 0. Well, that tells us that the denominator has to be 0 also. That's why we're allowed to use or able to use L'Hopital's rule. And if the denominator is going to be 0, that means 1 minus, and this happens to be 0 at x equals 2, so 1 minus f of 2 quantity cubed has to be 0. Or in other words, f of 2 quantity cubed has to be 1, so that means f of 2 has to be 1. You take the cube root of 1, you get 1. Now, if you applied L'Hopital's rule, which is where this expression right here came from, okay, I hope you can see my cursor, just in case you can't. I did L'Hopital's rule to get to this step right here. And then from that expression, they tell us the limit is 4. No, they don't tell us the limit is 4. The function is continuous because the function is differentiable. So that means the limit has to equal the function value. So since h of 2 is 4, the limit of h of x as x approaches 2 is 4. And so setting x equal to 2, the numerator is 4. And if the whole thing has to be 4, that means the denominator has to be 1 because 4 divided by 1 is 4. So f of 2 we found to be 1, so I plug that in. F prime of 2 is what we're looking for. And that, again, all of that denominator has to be 1, so that 4 divided by 1 is still 4. And then you can just solve that for f prime of 2 to get the negative 1/3. A little bit more of an involved problem. Some of you did didn't know what to do, but you did a good move by just applying L'Hopital's rule, because they gave you 1 point for applying L'Hopital's rule. So that should have been pretty straightforward. You just throw it out there and get a point. But hopefully you'll be able to reason through this better next time, if there is a next time. It is known that g of x is less than or equal to h of x for x between 1 and 3. Let k be a function satisfying g of x less than or equal to k of x less than or equal to h of x for x between 1 and 3. Is k continuous at x equals 2? For k to be continuous, we have two ways of showing that. It's either that k is differentiable, they didn't tell us that, or the limit as x approaches 2 of k of x is equal to k of 2. That's the definition of continuity. So if we jump down into this, well, we have to do a lot of justifying for this one. They tell us that g and h are twice differentiable, so that means they are continuous. And since g and h are continuous, the limit as x approaches 2 of g of x has to be equal to g of 2, and they told us g of 2 is 4. And then for the next line here, the limit as x approaches 2 of h of x has to be h of 2, since h is continuous, which is also going to be 4. Now, since k is trapped between g and h by the squeeze theorem, which they did say in the solutions that you do not need to mention. Okay, if you don't mention the squeeze theorem, you do not get penalized in this example or in this problem. That means the limit of k of x as x approaches 2 has to be 4 as well. All right, so now what else? They tell us that g of 2 is 4, which is less than or equal to k of 2, which is less than or equal to h of 2, which is 4. So that means k of 2 is going to have to be 4 as well. So the limit as x approaches 2 of k of x is equal to k of 2. So k is continuous. That should be at x equals 2. All right, let's get to the next question. So we're given this graph. Let f be twice differentiable function on the interval from negative 1.2 to 3.2 exclusive. F of 1 is 2, which I circled. The graph of f prime, the derivative of f is shown. So this is the derivative. The graph of f prime crosses the x-axis at x equals negative 1 and x equals 3. And has a horizontal tangent at x equals 2. Let g be the function given by g of x is equal to e to the power of f of x. All right, and they want us to find the equation of the tangent line to the graph of g at x equals 1. So g of 1 is equal to e to the power of f of 1. They told us f of 1 was 2, so this is going to be just e squared. Now I need the slope, so they take the derivative and apply the chain rule. Derivative of an exponential is itself, so it's going to be e to the power of f of x times, now that with the chain rule, the derivative of f, or f prime. So now plug in 1. We were told f of 1 is 2, so e now is going to be squared. F prime of 1, I go up to the graph and say at 1, the derivative is negative 4, as they told us, it's in the graph. So that means f prime of 1 is negative 4, and so our slope is going to be negative 4e squared, and then we just write the equation. I think that's a 2-point question. For B, it says for x between negative 1.2 and 3.2, find all values of x at which g has a local maximum. Okay, so we're looking for a local maximum. So we got to take a derivative. That's what we do. So looking for critical numbers. We take the derivative as we did earlier. We get this. We're going to set that equal to 0. The e to the power of f of x part's always positive for all x. So there's no critical numbers happening there. If we look at the graph, f prime is equal to 0 at negative 1 and 3. And then I just went in and said, well, let's go look at the graph. From around negative 1, the graph goes from positive to negative. So that means we're going to have a local max there. Around 3, the graph goes from negative to positive, so there'll be a local min happening there. We want the local max, so I just write the statement. There's a local max at x equals negative 1 because g prime changes from positive to negative at x equals negative 1. For C, what was the question? Oh, they gave us the second derivative, and they want to know is g double prime of negative 1 positive, negative, or 0. I'm going to tell them why. So they give us the second derivative. Plug in -1 for all the x's, and then let's simplify it a little bit. E to the power of f of -1. I don't know what f of -1 is, but I don't need to know it. F prime of -1 is 0, because we can see that in the graph. So that's 0 squared. Okay. And then I say plus a negative over here. Where am I getting the negative from? Well, f double prime is going to be the slope of this graph here, because this is f prime. So f double prime is the slope of this graph at -1. And the slope of this graph has to be negative at -1. You can see the graph is decreasing at that point, or the slope of the tangent line is negative. So we're going to have e to the power of f of -1, which is positive, times 0 plus a negative. Well, 0 plus a negative is negative. Well, I say this is positive here, that part's 0. So a positive times a negative is going to be negative, and so g double prime of -1 is less than 0. Lastly, for D, we're trying to find the average rate of change of g prime, the derivative of g over the interval from 1 to 3. They give you 1 point for just setting up the difference quotient so that you understand average rate of change. So g prime of 3 minus g prime of 1 over 3 minus 1. And we start plugging things in. Okay, e to the power of f of 3 times f prime of 3 minus e to the power of f of 1 times f prime of 1. F prime of 3, they told us that's 0. It's in the graph. So I don't care that I can't calculate f of 3, e to the power of f of 3, because f prime of 3 here is 0. So this being 0 means that whole thing is the whole product's going to become 0. We know f of 1 is 2. They told us that, so I get e squared here. F prime of 1 is -4. They told us that. And then just do the arithmetic if you want. All right, I hope that was helpful. If you need more help, then come by office hours, please. Go study.